On June 24, 1982, British Airways Flight 9 was halfway through a routine trip from Kuala Lumpur to Perth, cruising at 37,000 feet. In modern commercial aviation, a single engine failure is extremely rare. The mathematical probability of all 4 independent engines failing at the exact same time is so small that engineers consider it practically zero. But suddenly, an acrid scent of sulfur began filtering into the passenger cabin. Wisps of mysterious smoke started creeping through the air vents. Up in the cockpit, the flight crew immediately checked the weather radar to see what kind of storm they had flown into. This diagram shows what they saw. Absolutely nothing. The screen indicated a perfectly clear path ahead. Then, despite those clear readings, the impossible happened. One by one, all 4 massive jet engines choked, flamed out, and spun to a halt. The Boeing 747 was now a 300-ton unpowered glider. The crew was trapped in a paradox. A perfectly healthy aircraft was falling out of an empty night sky, and their instruments were telling them everything was fine. But the real danger had nothing to do with weather. Over 100 miles away, Mount Galunggung was actively erupting, blasting a towering column of volcanic debris directly into Flight 9's path. The problem was a blind spot in 1980s aviation technology. Weather radar is designed to detect moisture. Radio waves bounce off rain and return to the receiver. But volcanic ash is dry rock. Without moisture, radar pulses simply pass right through the debris without reflecting. The radar registered empty space. In reality, the jet was plowing at 500 miles per hour into a dense, abrasive mountain of floating rock, hidden by pitch-black night. By relying exclusively on instruments calibrated for standard weather, the aviation industry had left its crews blind to a massive geological hazard. So, what exactly happens when a jet engine swallows millions of microscopic rocks at cruising speed? Inside the combustion chamber, temperatures exceed the melting point of volcanic ash. Entering rock instantly melts into a thick sludge coating the turbine blades. This blocks the airflow required for combustion, choking the core until the engines completely shut down. As this mechanical collapse was happening outside, a very different kind of reaction was taking place inside the cabin. Captain Eric Moody picked up the PA microphone and delivered an announcement of severe British understatement. "Ladies and gentlemen, this is your captain speaking. We have a small problem. All 4 engines have stopped. We are doing our damnedest to get them going again. I trust you are not in too much distress." While high-temperature destruction was tearing through the engines outside, the flight crew maintained absolute, disciplined calm on the flight deck. Without thrust, the pilots had to point the heavy aircraft's nose down. They began a desperate glide, trading thousands of feet of altitude for the airspeed they needed just to keep the wings from stalling. That terrifying plunge is exactly what saved them. By dropping sharply in altitude, Flight 9 fell out of the ash plume and entered a lower atmosphere filled with much colder, denser air. This created a rapid thermodynamic reversal inside the engines. A massive influx of freezing air rushed directly over the glowing, molten ash coating the turbines. The sudden drop in temperature caused the liquid rock to solidify, shatter, and blow entirely out the exhaust. The very act of falling out of the sky provided the exact unintended mechanical remedy they needed to fix the engines. With the turbine blades cleared of debris, and just moments before reaching a fatal altitude, the flight crew successfully restarted the engines. The pilots quickly diverted the aircraft toward Indonesia, navigating a stressful approach before they safely touched down at the airport in Jakarta. Despite losing every engine on the aircraft at cruising altitude, all 263 passengers and crew walked away without a single fatality. The Jakarta incident led directly to the establishment of 9 volcanic ash advisory centers, a global monitoring network that now dictates flight paths to ensure no pilot flies blindly into a debris cloud again. What began as a terrifying freefall over the Indian Ocean resulted in a new set of safety protocols, replacing an invisible geological threat with the specific data needed to avoid it.